Alrighty, so we had gone through 26. So our next thing was getting into chain rules that like are a second derivative. So we'll find the first derivative and then we'll find the second derivative. So 30, y equals the cotangent of x. So we'd find the first derivative and then obviously find the second derivative thereafter. So what is the first derivative of cotangent of x?
Negative cosecant squared of x.
Yep, negative cosecant squared of x. Now, for the sake of doing the second derivative, it probably would be easier for us to think about this as negative and then cosecant of x squared like this. So then our second derivative, we take the derivative of the outside, so that would be the negative 2, and then cosecant of x, and then obviously that just becomes a 1, so we don't have to do anything else, times, now the derivative of cosecant is what?
Cosecant x. Cotangent x. Times
Yep.
cotangent x.
Times what?
Cotangent x.
Oh, yeah. Negative cosecant. I think you forgot the negative, but I don't remember. And then cotangent of x. So then just to multiply all this together, we end up with a positive 2 cosecant squared of x times cotangent of x. So that's our second derivative there. So now what they're doing is they're giving us the function of like, basically they're giving us a composite function, f of g of x. And then what they're doing is they're writing it as f of u is equal to something in terms of u instead of x. And then they're giving us u, which is really g of x. And so we're taking the derivative of both and multiplying them together. And then at the end, we're plugging in a number to actually solve it. So essentially, we're finding the slope. Like, ultimately, is what we're doing. Because that we're getting into, not with these ones, but the next chunk of problems is going to be finding the tangent line. So 34, we have f of u is equal to 1 minus 1 over u. U is equal to g of x, which is this 1 over 1 minus x. And they're doing it for when x is negative 1. So we're finding the derivative essentially of 1 minus 1 over 1 minus x, basically. But we're just doing it in chunks. They've already essentially chain ruled it for us. We just have to take the derivative of each piece. So what would the, well, I would probably rewrite this first as 1 minus u to the negative 1, obviously. But what would the derivative of f of u be?
U to the negative 2.
Yep. And then we would need to also do the derivative of g of x over here, or the derivative of u, however you want to think about it. So what would the derivative of this one be? You can either use a quotient rule or you can essentially use a chain rule with it if you're so inclined. Move it to the top.
1 plus x.
So if we did the quotient rule, which is what I did you try to do the quotient rule or did you try to
I try to do
chain rule, so you moved this to the top?
Yeah.
So if you do that, then we would have, let me just do this over here. 1 minus x to the negative 1. So we would have negative all of this. So 1 minus x to the negative 2.
Oh, that's it.
Not over. What am I doing? Times the negative 1 for the derivative of the inside. So you'd end up with positive 1 over this stuff, basically. So now I can take these things and wait. Hold on. I know what I need to do. So first of all, this is in terms of u and this is in terms of x. So I need to take, if this was u, I need to take this and plug this in for u here first. Basically doing u substitution. So I would have, this is 1 over 1 minus x all to the negative 2. So my derivative f of g of x,
Isn't it 1 minus x squared
where?
on the bottom?
This?
Yeah.
This is just plugging this in.
Yeah.
I just replaced this. So no, it's just 1 minus 1 over 1 minus x. I'm getting ready to multiply it by this though.
Okay.
So technically I could flip this now, because it's a negative exponent, to be 1 minus x squared. That gets rid of my negative exponent. So now I have basically, well, we essentially just take these two things and multiply them. So I have 1 minus x squared times 1 over 1 minus x squared. And so obviously that cancels that top and bottom. So the derivative of this whole thing is 1. So this wasn't a great example because technically I would have been plugging in negative 1 for x. But everything cancels, so I didn't need to in this one. So this would be your answer. But let me see. It looks like... I think 36 will give me something I can plug in, so let's try that one. It's a trig one, so things don't usually all cancel, so we'll find out. Alright, so f of u is equal to u plus 1 over the cosine squared of u. U is equal to g of x, which is pi x, and x is equal to 1/4. So again, we'll take the derivative of each piece. I would probably, with this one, change this to be u plus the cosine of u raised to the negative 2 like we did in the last one. Because even if you do a quotient rule, you're still going to have a chain rule in your quotient rule. So I might as well turn this into just a chain rule and not have to worry about it. And then over here, obviously, what's the derivative of pi x?
1.
Pi. Did you get that right on the test?
I got the derivative. It was just pi, right?
0?
Yeah.
The derivative of pi is 0? Yeah. I like throwing that one in there because well, obviously with one person, probably not as inclined to trick them. But when I've had like bigger classes, I always trick somebody with that one. They're like, 1. And I'm like, no. All right, so now I can take the derivative of this over here. So f prime of u, well, the derivative of u is just 1. And then over here, the derivative of the outside, I've got minus 2 times the cosine of u, but that cosine of u is raised to the negative 3 now, times the derivative of cosine is minus sine. And so then just to simplify it, I've got 1 plus 2 sine of u times the, I'm going to leave this as the cosine of u to the negative 3, but if you want to move it, you can. And then ultimately, let me back up. This is the part even I tend to forget. This pi x has to go everywhere there's a u. So it's going here, and it's going here to replace the u. So I'm going to have the derivative, basically with respect to x now, is 1 plus 2 sine of pi x, and then times the cosine of pi x, all to the negative 3. Now, all of this is getting multiplied by pi in the end, because that's how I find my chain rule of this original problem. So I'm going to multiply it by this value to get it. So at this point, I would go ahead and plug in 1/4, because with trig functions, things don't really cancel out very well. So I would rewrite this. So I'm just going to do f prime of 1/4 is equal to, I'm going to put this pi out front just because, 1 plus 2 sine of, that's going to end up being pi over 4, times the cosine of pi over 4, all raised to the negative 3. So we've got pi times 1 plus the sine of pi over 4 is root 2 over 2. So I've got 2 times root 2 over 2. And then times the cosine of pi over 4 is also root 2 over 2. But it's raised to the negative 3. So essentially, what I'm going to end up doing is flipping this over and cubing it. So I'm going to end up with pi times 1 plus the 2's here will cancel. And then if I go ahead and write this flipped, I'm going to scratch this out and write it flipped. 2 over the square root of 2 cubed. Then I would end up with the square root of 2 times 8 over 2 root 2. Root 2's cancel top and bottom. 2 goes into 8 4 times, so I just have 1 plus 4 inside, so this ends up being 5 pi. And so that would be your answer. Are you tracking?
Where did the 2 root 2 at the bottom come from?
I cubed the root 2.
Oh.
So 2 and the root 2 and root 2 became the 2, and then there was a root 2 left over. So I just kind of like skipped an intermediate step of showing this was like 8 over the square root of 2 cubed, and then turning that into what's right there. So basically, when you start these, if you need to rewrite something, obviously rewrite that first, and then take the derivative of both pieces that you're given, watching for the chain rule. Then you have to substitute in the u values because we got to get everything in terms of x. Then we multiply it by essentially the inner part of your chain rule. And then if needed, plug in the value for x, because obviously in the first one we didn't need to plug it in and everything canceled. This one we had to. But your answer should come out to be something that's like pretty nice and simple. All of them are either just like basically like a single digit over a single digit if it's a fraction, or like pi over something or something pi. They're not anything like crazy. My pages are all out of order, making sure we covered everything. Oh, I see it right now. Okay. All right, jumping down, 40. These ones say let's see. What happens if you can write a function as a composite in different ways? Do you get the same derivative each time? Chain rule says you should. Try it with two functions and see. So they break the function down for you in this problem in two different ways. Like, I don't know if you remember decomposing functions last year, but where you were given something and I like told you, a lot of them have more than one way you can like decompose them. Essentially this one is saying, does it matter which way I decompose it to get my chain rule? Well, I get the same thing no matter what I make my u. So we're just going to look at two different ways to do one of these and then move on to tangents. So 40, they give us the function sine of x squared plus 1. So the first option is going to be y is equal to the sine of u plus 1, and u is equal to x squared. And then the other option, which I'll write in a minute, is going to basically just be the sine of u, and then u is x squared plus 1. So we're just showing what happens with this individual situation. So we're doing the same thing we did to start the previous couple problems. So we're going to find the derivative of y and then the derivative of u, and then go back. So the derivative of this first one, they still give us a chain rule in this sense. They didn't really help us with that per se. So the derivative of sine is cosine of u plus 1. Now, the chain rule then says, obviously, the derivative of the inside. Well, the derivative of u plus 1 is just 1. So I don't really need to write anything, but just to remember, like, we are technically doing a chain rule, even though you don't really see anything else written there. So that's y prime. Over here, u prime is the derivative of x squared. So that would be 2x. So before I do anything else now, I have to take this x squared that was u and plug it in for u in this first thing. So then y prime is equal to the cosine of x squared plus 1. And then to get our full derivative, we would have the cosine of x squared plus 1 times 2x. So I can either put it in front or I can put it at the end. It doesn't matter, obviously. So 2x times the cosine of x squared plus 1. So that's one option for how it can be written. The other option in B, if they gave it to us as y is the sine of u, and u is equal to x squared plus 1. Derivative of sine is just cosine. So this is the cosine of u. The derivative of u would just be 2x, and that's it. So if we replace u with x squared plus 1, I would have the cosine of x squared plus 1, and then ultimately the derivative would be 2x times the cosine of x squared plus 1. So either way that it's decomposed, we get the same answer is all that's trying to show you. So that's like, we really only use this if you want to break down the function first, because if you were given this initial problem up here, we would just run a chain rule on this problem, like, which would obviously save a whole lot, because we would just go, okay, well, the derivative of the outside, which is just of the trig function, would be the cosine of everything inside, so x squared plus 1. And then we would say, okay, now the derivative of the inside is just 2x. So in one step, we can do what it just took like a lot to do. So I don't really use this method, but it's really just proving to you that no matter how you broke down any of the previous ones like that they were giving you, it would have worked the same way. So, and some people like to break them into their component parts. There's a little bit of calc too. Are you going to have to take more calculus in college with what you want to do? Do you know yet?
I don't think so.
Okay. Then you'll probably be fine, because you get into stuff where it's broken down. More so when we're going in reverse, not taking the derivative but working backwards, where you have to do things in sections. And so that's where breaking it down into its component parts can be easier. But if all you're doing is Calc 1, you won't really have to worry about that too much. We do a little bit with U substitution to make our life easier, but not really when it comes to derivatives like this. All right, I'm going to do the next two problems out of order because 46 is easier than 42, so I want us to see that one first, and then we'll go to 42. So 46, these ones want us to find the equation of the line tangent to the curve at the point defined by the given value of t. So they're giving us an x and a y, and they want us to find essentially the derivative of each of those. So they say that x is equal to 2t squared plus 3, and y is equal to t to the fourth, and t is equal to -1. So these are not exactly, but kind of like parametric equation stuff that we did very, very briefly last year, and I think there was a section early on in the book, our book this year, that may have had something about it. So anyways, the first thing I'm going to do is I'm going to find x and y, because I ultimately need the point where to find my equation of my line. So I'm finding the x and y value because they're not giving me the point straight up. So I'm going to plug in this over here to just get my ordered pair. So x is equal to 2 times -1 squared plus 3. -1 squared just 1, so that ends up just being 5. And then y is -1 to the fourth, which is just +1. So the point that I'm going to be dealing with is 5, 1. So this one's a little bit different. Instead of us just being given a function, we take the derivative and evaluate it at a point, and that's our slope. This one is going to require us to recall a little bit about slope in general to find its slope is the change of y over the change of x. So what we're going to do is we're going to take the derivative of y, get that value, and then put it over the derivative of x and get that value, and then that's going to give us our slope. So dx dt, and I'm writing it this way because I'm taking the derivative of x with respect to t, so I don't usually write like x prime or something like that. I write what I'm taking it with respect to. So the derivative of this would just be 4t, and then dy dt is 4t cubed. So I've got the change of y over the change of x to find my slope. So I would have 4t cubed over 4t. 4's cancel, a t cancels, and so I'm left with t squared. Now I can evaluate that for t equal to -1. And so -1 squared obviously is just 1. So that's my slope of my line. So just a different way that we can find our slope. So now I use this point that I found in my slope to write my equation of my tangent line. So y minus 1 equals 1 times x minus 5. Moving everything around. Y equals x minus 5 plus 1. So that's just going to be minus 4. And that's your equation of your line.
Is it cool if I leave it in point slope? Or do you want me to?
If they're just asking for the equation, yeah, it doesn't really matter. They're gonna put it in slope intercept form. I mean, I trust that you can like manipulate it over. On the AP exam, I think they will take it either way. But this isn't something that necessarily is a free response type question. It's more likely to be multiple choice. So just obviously you'd have to look at the options that they give you. But I'm pretty sure unless they specified that it has to be in a particular form on if it was a free response question, I think they're okay with either one. I mean, I wouldn't like move it to standard form because like we don't really use standard form for anything, but point slope or slope intercept should both be fine. So backtracking to 42 now just because it's a trig one. So I've got x is equal to the sine of 2 pi t and y is equal to the cosine of 2 pi t. And we're doing this for t is -1/6. So first I've got to evaluate each of these at -1/6 to figure out, what the value is. So x is the sine of -2 pi over 6, which is obviously just the sine of -pi over 3. So -pi over 3 is down here. So that would mean we have an x value of 1/2, and then a y value of -√3/2 on the unit circle. So that means the sine of -pi over 3 would be -√3/2. And then over here, y equals, well, I obviously know how this is going to cancel because it's basically the same thing inside. So the cosine of -pi over 3. So y is going to be +1/2 then. So you don't have to rewrite it as an ordered pair as long, you have the pieces, but I just like to do that to see it. So I've got to take the derivative of each of these pieces now. So what would the derivative of x be with respect to t?
Cosine 2 pi over t, or 2 pi t, and then this would be 2 pi times 2 pi.
Yep. And you can stick it at the end or in front. I usually like to stick the numbers in front, but it doesn't matter. And then how about dy dt?
Negatives, it would just be 2 pi times negative sign, or -2 pi.
Yep. Yeah, just depending on what way you write it, but yeah. So -2 pi times the sine of 2 pi t. So still same thing, even though obviously it's trig function, I'm still setting this up as the change of y over the change of x. So negative 2 pi sine of, I'm going to go ahead and plug in the number. So obviously negative 1 over 6 is going to cause that to become inside negative pi over 3. And then on the bottom, 2 pi times the cosine of negative pi over 3. 2 pi's cancel. So I've got the negative sine of negative pi over 3. So negative pi over 3 sine of that is negative root 3 over 2 times the negative is going to be a positive root 3 over 2. Over the cosine of negative pi over 3 is 1/2. So we just do that. Keep, change, flip. I end up with square root of 3. And then just need to write the equation. So y minus 1/2 equals root 3 times x minus root 3 over 2. Oh, plus. It was minus a negative. So now I've got, if I move this over, y equals the square root of 3x plus, that ends up just being 3 over 2 now, plus 1/2. So I end up with the square root of 3x plus 2. So yeah, you could either leave it there or take it all the way down. Any questions on that? Let me see what the last problem I gave you the other day was.
It was 27.
Okay. So then, let's see. 29, 33, 39, which is another one of those where you're just essentially finding the same derivative 2 different ways. And then 41 and 45. And then we'll plan to start, unless you have like questions tomorrow, or well, I'll give you time tomorrow to work on this, and then if we have time, we'll get started on the next section, and if not, we'll just do it on Wednesday. But this section I usually give at least 3 days, so.